और career change and certification also, ma'am.
Okay. So I believe most of you will be looking forward for PCNSE only.
Yes, ma'am.
Okay. All right. So this Palo Alto course basically is in fact designed for people who will be going for Palo only. And also keeping in mind, we have special paid, we have paid special attention towards the PCNSE exam. So whatever right now, as per the market requirement, like whatever the eligibility criteria they need. So actually we are also doing some sort of market research, and that's how we will be dealing with it. And anyway, so myself is Shagun, and I've been on Palo Alto training since last 4-5 years now. And I have also worked as platinum support in Palo. So where I dealt with few live cases and all. So that is just my experience, and now in training since last 4 to 5 years now, and been training all sort of people. Some are very fresher, some are experienced. So that's all. So that is my forte, and I'm also from computer science background, so that is all about it. PCNSE certified, especially for all of you who just want to get ahead. And
Congratulations, ma'am.
thank you. Don't worry, it's very easy. If you pay attention to your fundamentals, it's very easy. So basically, Palo Alto, it is like a domain that will be rooted from Palo Alto's cybersecurity mechanism. And the cybersecurity deals with how many times you have heard something is being attacked, something is being compromised and all. So to avoid such kind of attacks and all, we want to filter the traffic, whatever is reaching towards us means it could be with respect to your network also, it could be with respect to your being a user also, or it could be with respect to your any mobile application or on the laptop, any application. Maybe sometime people said they got hacked from your any from any, you can say, Instagram or something like this. So any sort of traffic that you want to actually filter whether this is a legitimate traffic or not, so that this kind of mishappening should not keep on happening. So here comes the topic. It is called your firewall. So let me just share my screen. I'm seriously sorry for these all traffic noises and all. Actually, today I'm in different city, so I had no choice. I'm really sorry for that.
Ma'am, I have a question.
Yeah.
What is the difference between UTM and firewall?
What is the difference between
UTM and firewall? Is this different features in UTM or firewall?
No. Firewall, it is like much more than your UTMs or some other. Even if you will combine all together your IDS, IPS, networking, perimetry devices, the networking perimetry plus your security devices. In fact, that will not be equal to firewall. So firewall, we do have two type of firewalls now in the market. Okay, so let's talk about now into the firewall stuff only. So firewall basically in a few years back, uh, they rooted from IDS and IPS softwares. So IDS was intrusion detection system and IPS was intrusion prevention system. So they were working on certain kind of, so these are nothing but designed piece of codes in some language. Most probably every IDS and IPS, they are developed in C language only, just for being an ease. And also C is a very effective language when it comes to provide security and hardware interactions. So IDS and IPS, they were actually programmed so that they can identify if anyone, for example, any file you are going to click on, uh, whether it is a legitimate file or it is going to be a virus. So that means, for example, if here it is this is my device, and if you are working from home, then ultimately you don't have any other idea. So that means you don't know whatever is coming towards you from the internet, you cannot trust it basically. And that is the reason internet traffic or internet, sometime it is called untrust network. Okay. So in Palo Alto also, what are the interfaces that will be leading towards ISP? Sometimes we call them, these are the untrust zone interfaces. So that's how they will work. Now talking about your IDS and IPS, so it is like a piece of software. So here it is like mentioned, every rule will be mentioned, like if this kind of data is coming. So data means what? Everything in computer networking that is either an IP traffic or it is an TCP traffic, DNS traffic, DHCP. So might be any kind of other traffic, for example, telnet. Then you do have HTTP, HTTPS, then FTP. These all kind just few examples only, right? So any kind of traffic that is involving IP addresses, that is called your IP traffic. TCP traffic, any service that would require TCP handshake to be occurred first, that is called TCP traffic. In TCP traffic, we will be learning TCP three-way handshake. In TCP three-way handshake, normally we call it SYN and SYNAC and then ACK. So that is the legacy that we have to carry on further. So this is called your TCP traffic. Everything that will be covered here, that is a TCP traffic. What is the example of DNS? How you can say, okay, something is related to DNS on internet is going on. How you can correlate DNS? What is DNS, by the way? Anyone?
Domain name server.
Domain name system.
So what is the job of your DNS? If you do have a department, that department called as DNS, so what is the responsibility of DNS basically? So DNS means
It resolves full qualified domain name to IP addresses.
not fully qualified FQDN only. It will resolve any URL to IP. Yeah, exactly. So for example, if I'm trying to type www.cisco.com, let's say, so this cisco.com, we know, because we are the human, we can understand in terms of names and all. What about your device? Your device, it is a computational device. So that means everything is mathematically programmed in such a magical way. So they do not know what is a cisco.com. They have a logic to work on, and that logic is called binary logic. So that binary logic is nothing but it is converting everything into zeros and one. Now in this time, your cisco.com is not getting converted into 0 and 1. So cisco.com, first of all, it will be converted into one IP address. So this IP address, we do have two types of IPs nowadays in the industry. One is called IPv6 and one is called IPv4. So in your course, we will be paying full attention to IPv4. IPv6, it is least covered here. So IPv4, it is what we will be doing Palo Alto course with respect to version 4. Then in IP address, what is so special? Like every device must need IP address. What is so special about IP address? Like why any communication cannot take place without IP? What is so special about IP? What do you think?
It is the address for communication in the layer 3 or network layer. So it is basically a logical address that is assigned to a systems or any host, so that it can communicate in the network it's in the internet.
Yeah, exactly. So point is, it is an address, right? So internet is what? Internet, it is a kind of, we also call it World Wide Web, right? If we have to design, if I have to, this is our globe or earth, and internet is also like this only. On earth, what we can find humans, other species also. On internet, you can find some other stuff. For example, you have servers, you have routers, you have switches, you have mobiles, you have tablets, you have PC, laptops. So this is the world of internet. We live in different planets. We do have different species over here. On internet, we do have different devices. So because we know each other by names, we are human are the best, creation of, you can say, from mankind or from God's side. Like we do have the brilliant brain in the whole history. So similarly, your internet is designed keeping in mind all these things, like, okay, fine. So there will be different kind of devices. Some of them will be called as your servers, IDS, IPS, firewall. We don't know, there are more than billions of types devices that you can have. So many antiviruses are there. So everything, now we are talking about the actual device. So device is a thing. For example, this internet is full of devices. We don't know which device is what. But one thing is common between all these things are they all are having, especially whosoever is actually searchable over the internet. So one thing is common. Every individual, they are having one IP configured on it. Okay, so that is the common thing. So every internet device that is working right now, my laptop also, your laptop, your device from which you are joining this Zoom session also. So they are not possible, like it is not at all possible that you won't be having IP and you are still on internet. If you want to use internet, or if you want to being a server, you want to provide the services to some client, again, client or server role, whatever you are serving, so you must have one IP. So IP, it is the building block for internet. So it is the way, it is the address where you have to go from and where you have to go to. So it will tell you about source and destination. Just like in our daily life, we travel from one place to another, maybe sometime for our job purpose, for some other personal reasons. So same thing on internet, IP addresses will keep on flowing on the wires from one place to another just to fetch your data. What data? Everything is a data only. Right now I'm on Zoom on live. So this is a data only. So this data has to be traveled from one place to another with the form of your internet traffic. And each internet traffic, it is labeled with IP address because there are billions and trillions of packets are flowing over the internet. We know each other, we listen each other, we judge, we sense those emotions. But what about these devices? These devices do not know who they are talking to, right? So the IP address is the only base. So they know, okay, they will ask you, are you this destination IP where actually I'm looking forward for it? So the other IP will say, yes, I am. So they have to actually prove themselves, like, okay, I'm the one to whom you are looking forward for. So that is overall idea. Everything is termed in terms of IP only. You want to send some data, you must have one IP. To whom you want to send data, you must have one IP for the destination. So everything will be an IP, and the data will be keep on traveling with the help of those IPs. Now, when we talk about your firewall, your servers and all other devices, every device will keep on varied. So these devices will be actually the way they work. So the way they live, that is different. Okay. For example, we human, the way we do the things or we eat, so that is different. Animals, they do the same thing in a different way. So it varies from person to person also. In computer networks, every kind of traffic. So I just before few minutes I mentioned we do have different kind of traffic. So now time to connect your all dots together, whatever we've been covering. So these all devices, so they are connected to each other. Let's say somehow, we don't know how they are connected, but somehow they are connected with each other. And these devices, they are, these wires are actually these wires are carrying your some sort of internet traffic. So this traffic can be either of them. Okay, so even if you want to just say you want to open https colon slash 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 www.cisco.com, just this one line, you know how many types of traffic it will generate. So first of all, it will generate DNS traffic because DNS has to be resolved in this one. So DNS will be covered here. After DNS, it has to fetch the IP of cisco.com. Let's say that IP is, let's take the example 1.1.1 only. This is not the real IP of cisco.com. I'm just taking an example only. So let's say that IP that DNS has given you, it is 1.1.1.1. And after this, now you have to start the TCP handshake. Why? Because this is which service it is using, HTTPS, and which port number it is belonging to. This is belonging to port number 443. As per the computer network rules, RFC number 1918, we have some services over the layer 7 of OSI model, which are actually incomplete without the TCP handshake. So that means we have two things. One is layer 7 and another one is layer 4. Here I'm talking about OSI for the time being. Layer 7 means all the things that I have mentioned here. DNS, so these are the things. Okay, so let me just retype them. What are the layer 7 things? For example, DNS, DHCP, telnet, then your HTTP, HTTPS,
All
and
protocols were covered in layer 7 in application layer.
yeah, so these are the services, actually we say them. It is like rarely said protocols. There is a reason why they are called being services. So okay, so these, for example, these are the just a few example from your layer 7. Services means why? Because there is a particular server for them, dedicated server. If you will see, you would have listened about, I do have a DNS server. Similarly, you might have heard about this guy, I have DHCP server. Telnet, you do have one remote access server or this service. So you know how many types, what are the various ways that you can take the telnet. So first of all, why do we need telnet? What is the significance of telnet?
To take any system, any networking device configuration, for configuration,
So
or troubleshooting purpose.
yeah, that means remote access, right?
Yes.
So we need remote access. So that means how many times of the types of application we have? We have on Windows, we do have RDP, remote desktop protocol. Then we do have SSH, right? And then we do have a PuTTY. On mobile phones also, on laptops also, we sometimes we have Splashtop. Then we do have one more application, it is called AnyDesk. So these are the tools, right? These are the applications that you can install on your device, and you can take the remote access from anyone wherever you want to do. Most of the time when you are in organization, you are working. So most of the organization, they do have Splashtop. So you will call your IT team. You will say, my device is not working. Then they will say, can I have the Splashtop ID or not? Then you will generate one number, you will share that number with your IT member, and he will be taking the remote access of your device, and they will do some installation or removing some unnecessary files so that your device should be working appropriately. So we ultimate thing is everything is designed for remote access only, even if it is RDP, SSH, PuTTY, anything. So their main purpose is remote access. So that is the reason it is not called a protocol, it is a service, it is a logic behind various other tools. So these are called nothing but tools only. So tool, it is why tool? Because your application is a tool by using which you are achieving your goal. So that is a tool only. Okay. So now telnet, it is a service that is actually introduced by your layer 7, and layer 7 will be responsible for whenever you generate any kind of traffic. In our case, this is what we are trying to open. So layer 7 is responsible for, first of all, extracting the information, which service you are going to use. So now your layer 7 will be detecting you are going to use a HTTPS. So that means port number 443 should be triggered now. So when this, there is a rule, all these services, for example, your telnet, HTTP, HTTPS, these are the services that cannot be started before having that TCP handshake done. So that is a must thing. So TCP is required for these services, HTTP also and HTTPS also. So, okay, let's say TCP handshake got started. Let me just remove this whole thing now. So this is my client and this is my server. So they are going to have first TCP is going to be done. So this TCP handshake is started. So that means from the client side, this is my server. So when I'm talking about server, so let me just draw some realistic some photo so that you can imagine. So this is my server. How this client and server, how I'm actually connected with the Cisco.com server, because through the internet only, right? Again, so you can imagine they are connected with each other, some sort of internet connection. So here you can say this is your cloud thing. So this is your LAN cable. It can be LAN cable or it can be Wi-Fi connection, anything. So there is a something that is there, your source IP is configured. So, okay, so this is your source IP from where the data is being generated. And your destination IP is this interface where the cable is connected, or maybe this is also on Wi-Fi. But if this is a server, for sure there is a LAN cable that is connected to it, and that is the destination IP for you now. So whenever your port number 443 is detected, time to send the TCP SYN segment from client to the server, where on the same interface where you have detected it, and on the same server, it is possible your server can be okay with without encryption, that is with encryption 443, and your server can also reply you back on port number 80 also. So you have to be very sure. So you have to say the server which service you want, HTTP or HTTPS. So now you are going to send the SYN packet, we normally call SYN segment occurring at port number 443. So you have to be very, very specific. Okay. And after that, your server is going to send you back with one more segment in reply. It is called SYN and acknowledgement. Okay, so that is called SYN plus ACK. So SYN acknowledgement means your server is saying, I'm acknowledging your SYN segment. SYN segment, it is like a request, very ethically requesting somebody, can you please spare some time for me, because I need your time for some time, right? So that is kind of an ethical way to request somebody. And then that guy is saying, okay, I have listened your request. So this is like acknowledgement, means acknowledgement to the SYN. It is saying, I have listened your request and I'm happy to serve you. So here I go. So that means server is also happy to have the connection with you. And last time, now your client would say, okay, fine, thank you very much. So let's have the connection now, and we can finalize few data between us. For example, I have that much of data to send you. Let's say I have 20,000 bytes to send you, or maybe I'm looking forward for this photo to be uploaded on the Cisco or whatever. So they will be talking about some sequence numbers here. So sequence number and acknowledgement number thing will be actually finalized in this stage. So it is called your acknowledge, ACK. So that is the reason it is called SYN. So SYN means this direction, and SYNACK, and then ACK. So three-way means there are three packets are generated from between client to server. So that is the reason it is called SYN, SYNACK, and ACK. It is called three-way handshake signal. After that, because of the port number 443, so there will be one more encryption handling process will be started. That is called SSL handshake. So that we will talk maybe in the later part. So that is called your SSL handshake. And SSL, once it is finished, there are 8 messages that we will be actually, these two devices will be sharing with each other. And after SSL, now HTTP will start. So now you can say here, the HTTP will come into picture. So from client to side, server side, you are going to say HTTP get request. You are saying, can you get me the home page for cisco.com or whatever the page it is asking. So that's how that it is working. So now overall idea is, if you have HTTP, will I have this SSL occurring between them or not? What do you think? Just port number, for port number 80 traffic, let's say TCP will happen for both cases. For port number 80 also, port number 443 also. I'm talking about SSL. Which port number will have SSL and which port number will not have SSL?
443 has SSL, but not 80. Because it's secure.
Right.
TCP.
Yeah. Very true. Correct. HTTPS, if we have to mention it, so I would say TCP handshake. Okay. Plus you're directly going with HTTP get request. That is equal to port number. Which port number we are talking about now? 80 only. That is HTTP service. And when I talk about TCP plus SSL and then HTTP, then it is called my port number 443, which is HTTPS. So that's how you have to understand the things. So this is just a glimpse over of all these things, how the things are actually working inside. So this is how in general life your packets are actually getting processed. So now you can see you are just trying to open cisco.com and look at this, how many types of traffic you are generating. You are generating DNS traffic also, you are generating TCP traffic also, you are generating SSL traffic also. So this is normally called VPN traffic also. So every kind of any kind of activity, they are associated with more than one traffic alongside, right? So that is why our internet is full of either at some point TCP is happening, UDP is happening, DNS is happening, but something is happening over this wire, these wires. So now let's say this is overall view, like what is happening over the internet. So we all are here to talk about more and more about your Palo Alto firewall. Okay, so basically your firewall, it is called a security device. Security device means because it has actually originated from IDS and IPS point of view. So I was saying IDS and IPS was filtering the traffic, whether a particular traffic is good or bad, legitimate or not. So on certain kind of these traffic headers. So we do have you heard the term of IP header? We do have IP header, TCP header. Similarly, we do have other headers also, DHCP header. And we do have DNS header. Every format, I mean, talking about your format, how these services are working further. So it will be mentioned in their rule book, you can say. So this rule book is called IP header. So how the IPs, that means source and destination IPs, will be making some sense in the traffic over the internet, that is actually mentioned in the IP header. So this is the rule. How these port numbers or your TCP SYNS and ACK is occurring, that is mentioned in the TCP header. Similarly, how DNS server will be allotting you one of the IP address, it is mentioned in the DHCP header. This is DNS header. So these all are kind of different traffic carrying their different headers. So IDS and IPS, their job is first of all to open these headers and to know what is exactly happening. If inside that packet or inside that header, anything that is seeming like not legitimate, it will not be processed further, it will be blocked. So how you can say something is, let's say I have a data over here. Okay, let's say I have data arrived over here. How you can say this data is good or bad? So I have two choices. Either this can be good or it can be bad. So how you will take the decision? Any idea? how something you will say this is good, how something you will say no, this is not good. In real life, you can take any example.
On the basis of
Experience,
past
Experience, right? Yeah. In real life, we have some sort of already existing experience.
So
So
here
we
traffic history.
traffic history, we call these, for example, yes, you are right. Traffic history means we do have some kind of a format available with us. Okay, we know if the traffic that is coming, if it is matching this, then it is a good traffic. If it is violating any rules over here, it is bad traffic. Okay, so these all are called your security rules. And in IDS and IPS, that means in security devices, these are called signature matching system. Signature matching. Okay, so that means whatever the data is coming, if it is a virus, definitely there is every virus carries something, it is called signature, security signature within it. So now if it is matching, we in IDS, IPS, firewall, all these devices, they do have one very good database. That is a database of what? Database of existing attacks. So that means you do have a very big database where all the security signatures from existing experience, you can say now you have that database where already these attacks have been occurred in the previous years. So now whenever new data is coming and it is being identified as an attack, you can match it to compare it here. If it is matching here, then definitely if it is matching with bad stuff, it is bad only. If it is not matching with bad, that means we cannot say it is good, but it is not, for the time it is not bad also, right? So it is like that kind of strict security instructions that we have to always keep in mind. So IDS and IPS, they were checking each and every kind of your data, and they were actually comparing them, their security matching were occurring. And then based upon those security matching, they were taking the decision whether this is an attack or not. And then accordingly, they were generating the alert system over the devices. The problem is, let's say, you can imagine this is my laptop. Okay, so here is my laptop. I have already clicked over malware over here. So here it is my IDS or malware, or not malware, some antivirus system that I have installed over here. So, but the problem is, it's that all the click has already happened over here. So job of IDS is, after that click, what has damage occurred to my device, it is able, this software is able to detect that damage. So detecting, okay, like this is being done. IPS means prevention system. So it will be checking whether for the similar attack, do you have any preventions available or not. If you don't have, then ultimately your device is totally gone. You have to format your device, right? So these things, IDS and IPS, was basically actually majorly designed for the end devices. We call them end device. Your laptop, your PC, your this printer and all these called your end devices, because some end user will be actually using them. So that is the reason it is called end devices. What about firewall? Firewall is not for any user. Firewall it is actually to facilitate the users. So it is not end user. It is called your network perimetry device. So this is a security device. So now what has occurred? These firewalls are basically, it is not for home purpose. Number one, the various organizations, they use a firewall so that their internal LAN can be saved, from this such kind of attacks and all. So in this case, that the one that I just shown you, my device is already compromised, right? I cannot do anything over here now. But in case of firewall, what will occur? This is my firewall. This side is whole my LAN. Okay, so you can imagine this is my organization. And in this organization, this is my LAN area. And anyway, you can imagine there is a switch or somehow the connections are happening. So this one side connection is going towards LAN, and this side connection is going towards your internet side, WAN side. So now when anybody will be clicking on anything, number one, here also, let's say your LAN user is going to click over a malware device, not malware device, malware link or virus link. So first of all, your data will be generated because it will be coming to here only. So once your data will be received by your firewall, it will be processed by a firewall. Then the decision will be taken care. And if this is actually generated from inside the LAN side, then it will be also detected and decided by your firewall whether the user can proceed it with further or not. So that will be blocked from here. So your end device is still safe. In case somebody else is trying to reach you, first of all, they have to go through this firewall. Then again, same process will happen. Firewall will process that packet and then they will decide whether I have to send it here or not. In that case, your LAN is again safe. So the overall idea is your perimetry device is actually keeping you safe all the time. So you are not interacting with your bad files all the time, just like before we were using. So your firewall is number one for your organization. It is not for your home internet purpose. Then each Palo Alto firewall, that can cost a few, INR in lakhs to, it will go very high cost also. So we do have some series of firewall that would be suitable for all kind of business or corporate words. So let's say some corporates, they do have very small scale companies and all. So they can go for low end series. Okay, so we do have low end series firewall. So here we have very small firewall that fall into this category. It is called PA, that means Palo Alto, and the firewall name is 200. Okay, in the same series, we do have other models also. For example, 220 is there. Then we do have 220R is there. So it is like that. Then if you have a medium scale company, then you can go for mid-range series of firewall. So in that case, you can go for some sort of, let's say, 800 series firewall. Again, the name will be in the same convention, PA 800 and all. So this is how it will be working. In 800 series also, you do have different models. And if you do have a very big large scale company where you have more than 10,000 servers also, especially for data centric oriented firewalls, now I'm talking about. So these are called high end series firewall. So we do have 3K, 5K and 7K series firewalls. So these are massive firewalls. So 7K series firewall, it is in fact near about a 4 feet chassis firewall. It is very big firewall. So that is, every firewall, it is having some sort of criteria that is defining it as it is as a low end, mid range, or your mid end, or your high end series firewall. So those factors are, let me just note down here only. Number one factor is number of CPUs. How many CPUs are being used? Number two, your number of sessions, that is called a session handling capacity. Okay. Number three is number of rules that firewall is supporting. Rules means your policies. Okay. So that is policies, how many policies and rules that your firewall is supporting. Number four is VPN tunnels, or we can say it is IPsec tunnels. Okay. We do have others also, other features also, like app ID throughput, threat prevention throughput, but we don't pay attention to them as much as like these four. So number of CPUs, how many CPUs are there? So that is a further discussion, like why we do have CPUs, because your firewall's internal structure, logically, it is designed into 2 different layers. Okay. Now let's talk about your logic behind your firewall, how this round thing is working. Round thing means what happened to a packet when it enters into the firewall, and how firewall will take the decision whether I have to process it further or not. So that is called your packet flow of the Palo Alto firewall. So let's get into it. Now we will go for the same topology. This is my firewall, this is my LAN, and this side I have ISP. Okay, So here the connections are somehow happening like this. And talking about your, let's say this is my PA200 series firewall. Specialty about PA200 series firewall is it is a very small firewall and it is having 4 RJ45 connectors. So that means this is Ethernet interface number 1, interface number 2, interface number 3, and interface, this is my interface number 4. So I have total 4 interfaces over here that can actually filter my traffic. Okay. So we do have other firewalls. So this is called your hardware based firewall. Firewall can be your software based firewall also. So we do have hardware based firewalls and we do have software based firewalls. Hardware means they will be named as just the way I told you. It will be named as a PA200 series firewall, 220. These all are hardware based firewalls. What about software firewalls? So we have VMware. So VMware is actually very, they do have a very good collaboration with Palo Alto. In fact, the internal team have been so fortunate to working with Palo Alto community. So I was, the part of them. So they do have a very good collaboration with the VMware. So whatever the trainings they are providing their internal engineers, so their labs and all, so everything lab is settled over the VMware only. So that is just virtualized firewalls. So every VM based firewall, they will be named as PA, VM, and it starts from different models and series. So first firewall, it starts with 50, then 100, then 200, 300, and so on. So same thing, the 4 factors that I told you. So that will vary from firewall to firewall. That means in VM50, we have only 50,000 sessions handling capacity of your firewall. But whereas in PA VM100, we do have total 256,000 sessions can be handled by your firewall at a single time. Or maybe it depends until and unless those numbers are not exhausted. So that is overall idea about how many types of firewalls are here. Now let's take the same example. Now, one of the internal user, here the LAN side user, let's say my LAN this side, it is 192.168.0.0's network, and this one is 1/24 I'm using here. Okay, so on firewall number 1, this is my interface that is using this IP, and this interface name is Ethernet 1/2. Okay, this interface name is Ethernet 1/1. This interface name is Ethernet 1/3. Similarly, this interface name is Ethernet 1/4. Okay, one more thing is your Palo Alto firewall. It is just like router, switch. We do have one operating system. Similarly, on your firewall also, we do have one operating system. It is called PAN-OS. Okay, so it is called PAN-OS, Palo Alto Networks Operating System. So basically, it is based on Linux environment. So Linux is the one that is the fundamental behind your operating system, how everything is working. And under Linux, we do have different kind of distributions. So one of them, it is called CentOS. Under CentOS, now the third layer come into picture, that is called PAN-OS. So that's how your operating system actually is layered together. So this operating system will be carrying out all those functionalities, features of Linux environment, whatever. So that is the reason it is also super fast and super secure system also. The file system is very effective because it is inheriting all the good points of Linux also. So now I said, logically, your firewall is actually divided into 2 sections. Okay. Now let's say I give you one statement. I said
one doubt here. These sessions, when a laptop is trying to access some content from internet, how this session is calculated? How many sessions will be consumed?
That is a session ID. Okay, for example, when we have a connection with our server, that there will be a virtual connection between the server software, and one connection will be from client software. So it will be created by the socket, right? Socket means that in computer networks, we have small programs. So these are called socket. Socket always represent your source port and your source IP. So combination of your IP and port is called a socket. So that session is representing both sides, your server and client, they are talking to each other. So there is a session going on. That is a different session. Here, what is the session? That is the different actually. Let me just give you idea. For example, when we were into the very fundamental education in computer science, we first thing that we learned, that I remember, my teacher said something is called data and something is called information. So that means data is a raw data. Information is meaningful data. Okay. So similarly, in Palo Alto, session means now if any device will be generating any traffic, it will be hitting here only. So for your Palo Alto firewall, it is a packet only, just a packet, which is just standing outside of your firewall. Once the firewall has taken care all the measures, security measures, so that's what the packet flow would work, that I'll tell you. So after having the decision that yes, it is a legitimate traffic, I will process it. So now you can imagine that data or packet is here. So now this is called a session. This is a packet, this is a session. Now let's say there is one more packet is arriving and it is disqualified as firewall is not going to take it further. So it is not going to be processed further. So it will not be turned into session. So it will be dropped then and there here only. But this packet, it is qualified as the because of certain checks. Those certain checks we will now cover how the packet will be processed under the packet flow. So these checks will identify whether a particular packet is it having that eligibility criteria to turn as a session or not. So that is a session. Session means now this session, there will be one session table, just like routing table or MAC table. Every data will be labeled with one session ID, and you can actually keep track of what happened to that session ID, what has happened. So that session ID will be, for example, I said PAVM 100, we do have 256,000 session available. Okay. So there will be a pool of number, any data that is coming towards the firewall and firewall has taken into consideration. Yes, I will be taking it further. So now it will allot one of session ID from all the good numbers between 1 to 256,000. Okay. So that is a pool of numbers. So let's say your session ID. So you are going to open that website only, www. This is your traffic that your one of the LAN user is trying to open. Okay. So once this kind of data is now we first of all, we have to set the base. So one of the user that is going to open this website. So what will genuinely will say, it will be received by the gateway. Gateway will send it to the internet and internet will give you the reply back. This is what it has to be occurred. But as per your Palo Alto packet flow, what will happen? So number one, your gateway will receive this data. Yes, that is true. So that means Ethernet 1/2 has received this data. So over here, I have to put forward every interface of your Palo Alto firewall. It is mapped towards a zone. Okay. So Palo Alto firewall, it is a zone-based firewall. So that means if I have 4 interfaces, it is Ethernet 1, Ethernet 2, Ethernet 3, Ethernet 4. If I have 4 interfaces, each interface will be having one zone mapped to it. It is your decision. You can keep all of them in zone 1 also, no problem, but they should map to a zone. Or you can keep it in zone 1, and second one, you can keep it into zone 2, zone 3, zone 4. That is also possible. Maybe you can keep these two into one zone. You can keep these two into one zone, or maybe any other combination. There is no problem at all. So, but idea is there must be a zone. Zone means it should be like a groupism must be there. And this is all about physical interfaces. What about your logical and virtual interfaces? Let's say I have one loopback interface. Do I have to map the zone here? Any idea?
No.
So any kind of interface, whether it is physical or it is virtual, logical, this zone is so strongly implemented on all type of interfaces. So that means every kind of interface, even your tunnel interface, IPsec tunnel also, there must be a zone associated with it. So let's say, as per my topology, this side is called LAN zone. Okay, you have to just name it. So this is called my LAN zone. And this is called, I said, this is my WAN zone. And here, I did not configure these two interfaces, so I can just leave them unconfigured right now. I'm going to process my packet from here to here for the time being. So now my Ethernet 1/2, it has received one packet over here. Now, first stage of Palo Alto firewall's packet flow would start. We do have 4 stages. First one is called ingress. Second one is called your slow path. Third one is called your fast path. Fourth one is called your egress. Okay, so talking about the very first stage, that is ingress. Ingress means whatever the data is incoming. Ingress means in means incoming data. In Palo Alto, most of the security devices also, not just Palo Alto, we call it ingress. Ingress means the incoming side. So now it will check some very special terminology over here. It is called 6-tuple information. So it will check the 6-tuple information. What do we have in that 6-tuple information? We have source IP, we have destination IP, we have source port, we have destination port, and then we do have protocol number, and then we do have security zone or ingress zone. Okay. So now let's fill these all details. Let's say PC number 1, whose IP is 192.168.0.2. He's the one who has actually generated this traffic. So my source IP is going to be this. Okay. What about destination IP? Let's put Cisco's IP. For the time being, I'm going to put 1.1.1.1 only. Source port, we do have a very good logic behind port numbers also. Basically, we do have 3 categories of port number. One is called well-defined port number. Another one is called your reserved port number. Third one is called your random port numbers. Okay. What I'm talking about is, when we talk about port numbers, we do have categories. Number 1 is called your well-defined port numbers. Second one, it will be the range of these all things will be from 0 to total port number. We do have 65536. So that range is 0 to 65535. So out of these total, these 65535 range, first 0 to 1023 port numbers are called your well-defined port number, or if you can imagine any port number 443, it will come under well-defined port number. Telnet, port number 23, well-defined port number. Port number 80, well-defined port number. So well-defined port numbers, always actually it will be telling what is your destination port number. And second category is, second category is called your reserved port numbers. So in reserved port number, they start from 10242 all the way up to 49151 series. So here we do have some companies who will buy their special port numbers and they will use it for their internal or remote site VPNs. So for example, in Palo Alto, we do have 2 port numbers. They do have, one is called 4501, another one is called port number 27000. So these two ports they have bought, they have paid for it, and these two port numbers are reserved for their internal VPN connections. So this will never ever come into picture in the open or untrusted internet. Then we do have third category. It is called random port numbers. So random port numbers are starting from 49152 to all the way up to 65535. So this is where your source port will be falling in the range. So this range, well-defined port number will be reserved for your destination, and your random port number, this range will always be for your source port. So let's say my source port is 50,000. It will be randomly picked. What about my destination port? Can anyone tell me what is my destination port in for this traffic?
443.
Yeah, so it is 443. Now, something is called protocol number, and there is another thing that is called port number. What is the difference between port and protocol number? So, in the beginning only, we said there are two functionalities of OSI. One is layer 7 things, another one is layer 4 things. Layer 7 things are called your services. Layer 4, all the protocols are called your protocols. So every protocol that will be mapped to layer 4, that will be having its protocol number. For example, TCP, UDP, we do have protocol numbers for them. Whereas HTTP, HTTPS, we do not have protocol numbers for them. We do have port numbers for them. So it is a rule. Every port number, it is dependent on one protocol number from layer 4 that will be responsible for delivering that service from client to server, right? So that means a protocol number. HTTPS is basically dependent on TCP handshake. So that is why TCP is the protocol going to be the protocol here. But we do have a number associated with TCP. What is that protocol number?
6.
Yeah. So we do have the protocol number as 6 as a TCP. It is denoting TCP only. Last and the sixth entry is from which zone you have actually received this data. So that is called security zone or ingress zone. So I have received from LAN zone. So here I would say LAN. So this is the pre-processing that I have to collect. It is called 6-tuple information. And this 6-tuple information, if it is looking good, good means there is no problem. That means no source and destination IPs are same. No source and destination ports are same. So it is kind of genuine 6-tuple information. After that, your firewall is going to consider it, and there will be one hash code applied on this one. Okay, so there will be one hash code, hash algorithm will be applied on this one. That hash code will give you something, a mathematical number that will be related to your session handling capacity number only. So that is called your flow key. Okay, we do have different flow keys also, but for today we will only see it will be creating one flow key. Let's say my flow key is 09. So this is my flow key. After this flow key, my ingress, it will check what kind of data it is. Is it a VPN data or not? Everything is being identified here only by seeing the port number. So now my firewall is saying this is the flow key. Now I have to check. You can imagine your packet is still here. It is not even inside the firewall. So packet is still there only.
Just one doubt. This flow key 9, how is it derived?
Yeah, it is like one hash algorithm will be applied on this 6-tuple information, and it will be giving you the input will be this, output will be one number.
Okay.
Okay. So this flow key, now you have to check with respect to these all things, you have to check for 3 things. Now you are going to enter into the stage 2 of the packet flow. Stage 2 is called your slow path. In slow path, you will look up for everything. So you will check first, do I have the routing? Do I have the netting? And do I have the security policy? Routing means we do have something called virtual router existing already here. So that means internally at your firewall, there is something called virtual router. Every interface, when you will be configuring that interface will be, it has to be participated in the virtual router if and only if that is layer 3. So all the layer 3 type of interfaces, we do have multiple types of interfaces of the firewall also. It is going to be another discussion. But if your interface is having one IP address configured on it, so there, there is an option that you have to select the virtual router entry. So you have to select the virtual router. So let's say internal somewhere here, there is a program module. It is called virtual router. Okay, so here it is called your virtual router also. So this virtual router, it is the main, router, or you can say that is actually making all these interfaces communicating with each other. So this is this. You can see the routing table also of your firewall. You can see easily where Ethernet 1/1 and Ethernet 1/2 they are talking to each other, just because they have selected their default router as virtual router during the configuration. So if you have selected during the configuration virtual router as the default router, then routing checkup is done, because it will check the source is Ethernet 1/2 and destination zone is WAN that is configured on Ethernet 1/1. Both are participating in virtual router. So first check is good. Second check is netting. So because now see, this is your private zone, and obviously this guy is the ISP facing. So there are no chance like it will be having private IP configured on it. So it will be a public IP. So that means if your traffic is going outside, it will be natted over here with this public IP. So it will check, do I have the NAT over here or not? So definitely there will be one NAT configured on it. We call it source NAT, because you are going to change the source address of your packet. So natting is also true. It is matching a criteria. What about security policy? Now security policy is saying what is the purpose, what exactly you want to do. In routing, you were only checking from Ethernet 1/1 to Ethernet 1/2. Do we have a way in the routing table or not? You were not checking for what purpose you have to actually contact these two interfaces. Now security policy will be actually going through the details of these all things. So it will check, okay, what is the purpose? HTTPS service. Okay, so what is the source zone LAN? Do we have any security policy which is mentioning if the traffic is coming from source as LAN, destination going to WAN, and they have allowed the services as HTTP and all the internet applications are allowed, then you can say this packet is matching one security policy. So here is also a yes. 3 yes means now you are saying your packet, come on, welcome, coming in. That's all. Now, the moment this packet is coming inside, this flow key is turning into one session ID. So now it is called a session. So this is turning into session ID. So this is session ID. Let's say it may or may not be the same number, but for just an ease, I would say now this flow key, which was used to be called as 09 as flow key, now it has the session ID. And this is your fast path. Fast path means you are executing everything. So now your packet is not just inside, your packet is already traveled from here to here. It is executed. It is with your Ethernet 1/1. So now the last stage, it is called your egress. Egress means the time to send out of it. So egress means exit. Who is your exit? So hand over the data to exit interface and it will be processing it further. That is how your packet flow would work. It is just, I would say, every different kind of traffic will have its own different kind of packet flow. So for example, if you have some tunnel traffic, IPsec traffic, there will be a different packet flow. So that's how your packet flow on Palo Alto actually works. Now, if you have any question, you just do let me know. Any questions?
Yeah, so I have one question. You said the slow part is a combination of, we can say, routing, netting, and security, right? So once everything has been checked, from the firewall end, and then it come into the firewall, and then it will going to be a session ID, which
Hmm.
is our first part, correct?
First path means you have implemented all those routing, netting, and security policies. You have executed them.
Yeah, okay. So check into the slow part, all things are going to be checked out, right? I mean the routing,
Yeah.
then netting and security, correct? And if everything has been perfectly available over there, then it will be going to be as a session ID, which is our first part, correct? Okay, okay.
You can take one example from the courier. I normally give this example to my classes. When you want to send one courier from city 1 to city 2, right? So